Have you ever gazed up at the sky and wondered about that brilliant ball of light that provides us with warmth, light, and life itself? That's the Sun, the center of our solar system and a spectacular star that holds countless mysteries. The name, Sun, itself might seem quite common, but have you ever wondered if it has a more official name and asked yourself questions regarding it? Let us help you with those questions in this video. In scientific terms, it's referred to as Sol, derived from the Latin word for the sun. The concept of the sun's name might seem simple, but it's a crucial element in understanding the star that lights up our world. In this video by Academic Block, we'll embark on a journey through the fascinating realm of the sun, exploring its anatomy, structure, the energy it emits, radiation, and so much more. Whether you're a seasoned space enthusiast or just starting to explore the wonders of the universe, this video will shed light on the captivating world of our sun. The sun's large size and immense mass are fundamental factors that contribute to its gravitational influence on the solar system. Diameter of the sun is approximately 1.39 million kilometers. This measurement is also roughly 109 times the diameter of Earth. While the mass of the sun is approximately 1.989 into 10 raised to 30 kilograms. This mass is approximately 333,000 times the mass of the Earth. At the heart of the sun lies a core where an incredible process known as nuclear fusion takes place. This is where hydrogen atoms are fused together to form helium, releasing an enormous amount of energy in the process. This energy then radiates outwards, eventually reaching the surface of the sun known as the photosphere. The photosphere is what we see when we look at the sun, a bright, glowing disk. Beyond its visible surface, the sun's outer atmosphere, the corona, is a mesmerizing halo of plasma that extends into space. The corona is incredibly hot, much hotter than the surface of the sun itself, and it's responsible for the beautiful phenomenon we witness during a total solar eclipse. It's important to note that the sun's lifespan is measured in billions of years. It was born around 4.6 billion years ago and is currently considered middle-aged. But don't worry, it still has several billion years to go before it exhausts its nuclear fuel. When considering the composition of the sun, we find that it's primarily made up of hydrogen and helium, with traces of other elements. The core of the sun generates intense heat and energy that radiates outward and power our solar system. But how hot is the sun? Sun doesn't have a single consistent temperature throughout. Instead, its temperature changes dramatically from its core to its outer layers due to the complex interplay of nuclear fusion, convection, and radiation within its interior and atmosphere. Here are some key temperature ranges for various parts of the sun. At the very center of the sun, where nuclear fusion reactions occur, the temperature is estimated to be around 15 million degrees Celsius. The photosphere is the visible surface of the sun that emits light and heat. The temperature of the photosphere is around 5,500 degrees Celsius. Chromosphere is the layer above the photosphere. The temperature in the chromosphere can vary, but it typically ranges from about 4,000 to 20,000 degrees Celsius. Corona is the outermost layer of the sun's atmosphere. The corona is extremely hot, with temperatures ranging from 1 to 3 million degrees Celsius. The reason for this high temperature is not yet fully understood and is a topic of ongoing scientific research. Now let's dive in the daily phenomenon of the sun. The study of the sun's behavior, known as solar activity, offers a window into the dynamic interplay of celestial forces that shape not only the solar system but also our home planet, Earth. This captivating field of science delves into the mesmerizing phenomena of solar flares, sunspots, and solar wind, uncovering the profound impacts they have on our planet's environment and technology. Among the most dramatic displays of solar activity are the solar flares, intense bursts of energy that manifest as brilliant flashes of light and high-energy radiation. These explosions occur within the sun's atmosphere, triggered by magnetic interactions. Solar flares release immense amounts of energy, equivalent to billions of atomic bombs, and propel particles and radiation into space. While these cosmic fireworks are captivating from a distance, they can have tangible consequences on Earth. Solar flares can disrupt radio communications, navigation systems, and even power grids. Their high-energy radiation poses risks to astronauts in space and can impact the health of airline passengers and polar explorers. Researchers diligently monitor solar flare activity to better predict when these energetic events might occur, enabling us to mitigate their potential impacts on Earth's technology and inhabitants. Dotting the Sun's surface, sunspots reveal the Sun's ever-changing nature. These temporary dark patches are cooler regions caused by intense magnetic activity. Sunspots often occur in pairs or groups and can persist for days or weeks before fading away. They are windows into the Sun's magnetic dynamism, and studying their patterns and behavior provides insights into the Sun's inner workings. Sunspots are indicators of solar activity cycles, which typically last about 11 years. These cycles peak in activity, characterized by an increase in the number of sunspots and solar flares, and then decline in a cyclical rhythm. Researchers observe sunspot cycles to better understand the Sun's magnetic behavior, which influences space weather and Earth's magnetic field. Streaming outward from the Sun's corona, the solar wind is a continuous flow of charged particles, primarily electrons and protons, that sweeps through the solar system at supersonic speeds. This cosmic wind shapes the environment of space, influencing the magnetosphere of planets and interacting with their atmosphere. Earth's magnetic field acts as a shield against the solar wind's direct impact, but this interaction can result in mesmerizing auroras, or northern and southern lights. Additionally, the solar wind can compress the Earth's magnetic field, leading to geomagnetic storms that can disrupt power grids, communication systems, and satellite operations. These storms can pose challenges for space missions and technological infrastructure, making the study of solar wind crucial for safeguarding our technological society. The interaction between the solar wind and our planet's magnetosphere can lead to phenomena like the northern and southern lights, also known as the auroras. Now let's talk about the space missions which were solely focused on the Sun. The Sun, that radiant celestial body that graces our sky every day, has been a subject of human fascination for centuries. Its energy sustains life on Earth, and its mysteries have spurred scientists and space agencies from around the world to embark on a series of remarkable space missions. These missions, launched by various countries and organizations, aim to unravel the secrets of our nearest star and deepen our understanding of the universe. Let's take a keen look through some of the notable space missions to the Sun. Parker Solar Probe by NASA, USA. Launched in 2018, the Parker Solar Probe is a pioneering mission by NASA. Its mission is to touch the Sun, to fly closer to it than any spacecraft before. Equipped with state-of-the-art instruments, the probe will study the Sun's corona, solar wind, and magnetic fields up close, providing insights into solar activity and space weather that impact our planet. The Parker probe is planned to make multiple close approaches to the Sun, gradually getting closer with each orbit. Its closest approach, or perihelion, is expected to take it within about 6.4 million kilometers of the Sun's surface. At its closest approach, the heat shield is expected to experience temperatures of over 1,300 degrees Celsius. While using the thermal protection system, the spacecraft's instruments and systems will be kept at much lower temperatures. Solar Orbiter by ESA and NASA. A joint effort between the European Space Agency, ESA, and NASA, the Solar Orbiter was launched in 2020. This mission aims to observe the Sun from a unique perspective, offering a view of its polar regions. By studying the Sun's polar magnetism and solar wind, scientists hope to gain a more comprehensive understanding of solar activity. Adifear L1 by ISRO, India. India Space Agency, the Indian Space Research Organisation, is contributing to solar research with the Adifear L1 mission. India successfully launched its Adifear Sun mission on September 2, 2023, Adifear L1 aims to study the Sun's outermost layer, the corona, and explore the mechanisms driving its variability. It will be placed in a halo orbit around the Lagrange point or L1 of the Sun-Earth system, which is about 1.5 million kilometers from the Earth. A satellite placed in the halo orbit around the L1 point has the advantage of continuously observing the Sun without any occultation. Adifear L1 is expected to provide crucial information on coronal mass ejection, coronal heating, pre-flare and flare activities, dynamics of space weather, and propagation of particle and fields. There were also some more noteworthy space missions like Solar and Heliospheric Observatory, Hinode, Yoko and Ulysses. These missions, representing a collaborative global effort, have illuminated the Sun's intricate dynamics, helped us understand space weather, and shed light on the fundamental processes driving our solar system. But the Sun is more than a star which helps us to survive. It is also seen as God and symbol of faith for many civilizations. The Sun, that radiant beacon that illuminates our world, has captivated human imagination across cultures for millennia. In the realms of Indian, Greek, and Roman and other mythologies, the Sun takes on various personas, each laden with symbolism and significance. In Indian mythology, the Sun is associated with god Surya, who rides a chariot of 7 horses which depict 7 days of the week, and he himself is believed to be source of light and energy. In Greek mythology, Helios, the god of sun, is also seen as source of light and energy. He too rides a chariot and is believed to bring day and night for the mortal realm. In Roman mythology, folks refer to the sun god as Sol Invictus. This deity represents the victorious and eternal nature of the sun's power, often depicted as a radiant figure riding a chariot across the heavens. In the rich tapestry of ancient Egyptian mythology, the sun is personified by Ra, the revered god associated with creation, light and life. Ra is often depicted as a falcon-headed deity, and he's believed to be the creator of all things. In Japanese mythology, Amaterasu occupies a central role as the goddess of the sun and a major deity in the Shinto pantheon. Amaterasu is believed to be the ancestor of the imperial family, and her radiance is associated with purity and divinity. In Norse mythology, the sun is represented by Sol or Sunna. Sol is a female figure who drives the chariot of the sun, illuminating the world during the day. Goddess Sol has another personification of the sun and is often associated with healing and protection. In Aztec mythology, Huitzilopochtli, the god of war and the sun, plays a significant role. He's often depicted as a hummingbird or an eagle, representing his association with the sun's energy and the sky. These diverse mythologies from around the world demonstrate the universal fascination with the sun as a symbol of life, light, and cosmic order. Each culture's narratives offer unique insights into how humans have woven the celestial body into their spiritual beliefs and cultural identities. In a world where scientific literacy is more important than ever, understanding the solar magnetic field and the incredible phenomena associated with the sun can ignite curiosity and inspire learning. This video at Academic Block, crafted based on thoroughly researched scientific literature, aims to present these concepts in an interesting, easy-to-understand manner, making it useful to all. Please comment below your suggestions or criticism on this video, so that we can improve our future videos. Thanks for watching.